A bullet 10 gram leaves the barrel of a gun with a velocity of 600 meter per second. If the barrel of the gun is 50 centimeter long and mass of the gun is 3 kilogram, then value of impulse supplied to the gun will be. Okay, so first let us write down the given statements. So we have mass. So we have mass of the gun, which is given to us as 3 kilogram, right? So mass of the gun is 3 kilogram. And then we have mass of the bullet, which is given as 10 kilogram, 10 gram, which we'll take it as 10 into 1 gram, which is 1 gram, 10 to the power minus 3 kilogram. Therefore, we have 10 to the power minus 2 kilogram. Now, velocity of the bullet is given 600 meter per second. So we take VB is equal to 600 meter per second. Now, why have we taken mg, mb, and VB? Okay, before that, I hope this given data is clear to you. Now what we'll do is we'll try to understand what the question demands. This is what the question actually says, that we have a gun. So this whole system, actually this whole diagram represents the gun and the bullet, bullet being represented by the red one here. So we have the gun and the bullet as a system, right? Bullet plus gun is a system here. So we have this complete system before firing and after firing. Now see, before firing, we have a gun and a bullet. After firing, the bullet leaves the gun, but still we consider this to be the one complete system. Now, since bullet and gun are the system, we can say that the net external force, let me just write it down one more time. The net external force acting on this system is 0. Why is it 0? Because the bullet is moving due to the chemical reaction that is taking place, due to the energy obtained from the chemical reaction taking place inside the bullet. So it is not that someone from the outside is forcing this bullet. No. Well, actually, yes, we are triggering the gun, but that's not the point. The point is that whatever caused this bullet to move, it's actually is taking place due to the gun here, right? So the bullet and the gun, when considered as a system, the total net external force acting on it is 0. And if total net external force acting on it is 0, then we can say that delta P is equal to 0, or the change in momentum. Write down that also. Therefore, we can say that the change in momentum is also equal to 0. Now, when change in momentum is equal to 0, we can say that P is a constant. Why? Say, if we say that d by dx of P is equal to 0, it simply means that P is a constant. And if P is a constant, we can say that we can further say that P initial is equal to P final. And now this initial momentum will have components of both gun as well as the bullet. Final momentum will also have components of the gun and the bullet. Okay, now let's write down this equation. So this is the initial condition. Okay, for clarity, let us write down this also. So this is the initial condition and this is the final condition, right? Okay, now Pi is equal to Pf. Now Pi will have two components, one for the gun and the other for the bullet. So this component here represents the conservation of momentum for gun, and this one represents the conservation for bullet. Again, the same logic. We have this for the gun and this for the bullet. Okay, so initially the gun is at rest, so we can say that UG, initial velocity of gun, is equal to 0, and initial velocity of bullet is also equal to 0. Now mass of bullet is known, initial velocity of bullet is equal to 0, mass of gun is known, initial velocity of gun is also equal to 0. So UG is equal to 0 here, UB is also equal to 0, and therefore we can say that this complete initial term is actually ruled out and it's 0. So this is equal to mg into vg plus mb into vb. Now, since this complete term is equal to 0, we can transpose this mb vb to the LHS, and therefore we have minus vg. So if I have to write one more step, this would actually look like this: minus mb vb, right, is equal to mg into vg. And therefore, what is mg vg? Therefore, we can say that mg vg is minus mb vb, minus mb vb, the whole divided by mg is equal to vg. I just written it in a more organized manner here. So we have minus Vg is equal to mb by mg into Vb. Okay. Now this minus Vg is actually what we call as the recoil velocity of the gun, right? So this is what we call as the recoil velocity of the gun. Okay. Now, therefore, we can say that minus Vg is equal to what is mb? We wrote it earlier that mb is mass of the bullet, which is 10 into minus 2 kilogram. mg is mass of the gun, which is 3 kilogram, and then velocity is 600 meter per second. Now, as usual, we'll put the constants together. So we'll put all the constants together. So 10 to the power minus 2, 3, and 600 constants. So we just put all those together. And what will be the unit? See, kilogram by kilogram will, okay, now since being an objective class exam, there is no point in talking this, but still, just to make sure that the concept is clear. So 10 to the power minus 2, these two will cancel, 6 by 3 is 2, and therefore we get minus V is equal to 2. Or therefore we can say that recoil velocity of the gun here is actually 2 meter per second. Okay. Now coming to the final part. Now by impulse momentum theorem, we have that impulse is equal to change in momentum. Now which component are we talking about? This impulse can be for both gun as well as for the bullet. So it can be for the gun and the bullet as well. But we are talking here specifically about impulse of the gun. So impulse of the gun is equal to change in momentum. So impulse of the gun is equal to change in momentum of the gun. Change in momentum of the gun is equal to mass of gun. Sorry, my bad here. Mass of gun into initial velocity of final velocity of gun minus initial velocity of gun. Mass of the gun is 3 kilogram. Final velocity of the gun we just determined to be 2 meter per second, and therefore we have 3 into 2 meter per second into kilograms. Okay, so I've written that here. So this becomes 3 into 2 is 6 kilogram meter per second. Now, those who have the complete question, you may find a different unit there, right? So let me just explain you that part also. So if I multiply this here, say if I multiply this by second and divide it by second, I can write this further as is equal to 6 kilogram meter per second square into second, right? Now what is kilogram meter per second square? Kilogram meter per second square is nothing but 1 kilogram. So this is actually 1 kilogram per 1 meter per second square is nothing but the unit of 1 Newton. So this is 1 Newton into second, and therefore we have 6 Newton second as the option. Three forces, F1 is equal to 10 Newton, F2 is equal to 8, and F3 is 6 Newton are acting on a particle of mass 5 kilogram. The force F2 and F3 are applied perpendicular so that the particle remains at rest. If the force F1 is removed, then the acceleration of the particle is. Okay, so first let us write down the given things, which is F1, F2, and F3, and then we'll visualize it by drawing a diagram. Okay, so this means we have F2 and F3 which are acting perpendicular to each other, right? And then we have F1 which is acting in some other direction. And the values are F1 is equal to 10 Newton, okay, F2 is 8, and F3 is equal to 6 Newton. Now see, what we can say is we know that resultant of two vectors, when the angle between them is 90 degree, is actually given by R is equal to root of, in this case, F2 square plus F3 square, right? So the resultant vector would actually be root of 8 square plus 6 square, which is root of 64 plus 36, which is equal to 10 Newton, right? So the resultant vector which acts like this, right? So yeah, so this is the resultant vector, or let us say this is F resultant due to 2 and 3, which means we actually can replace this complete diagram, right, with only two forces, which is F2, 3 and F1. Okay, let me draw one more diagram to explain that. This diagram makes more sense. So now we can say that instead of F2 and F3, we can now replace F2 and F3 by the resultant of this, which I have written here as F23, and this is F23. So now instead of having one F1, F2 and F3, we only have two forces, which is resultant of F2 and F3, which is F23, which is F23 or F net, and we have only F1 and only F1, which means this 5 kilogram body is now experiencing only two forces, which is F net of 23 and F1. Now, according to the question, what happens is F1 is removed from the system. So in this case, what is removed? Vector F1 is removed from the system, in which case what happens? This body remains the same, mass is 5 kilogram, and F net here actually becomes F net 23 actually becomes the net external force acting on this body. Why? Because F1 is no more present here. So what is F net? By Newton's law of motion, we have F net is equal to m into A net. So we can write that F net is actually F net 23, right? F net to 23. So we can write that resultant is equal to 10 Newton, which actually is the F23 is equal to mass, which is 5 kilogram into A net. So what is the resultant? The resultant is 10 Newton. So 10 Newton is equal to 5 kilogram into A net, and therefore what is A net? A net becomes 10 by 5, right? 10 by 5, which is equal to 2 meter per second square. So the correct option is 2 meter per second square. An average force of 125 Newton is applied on a machine gun firing bullets each of mass 10 gram at the speed of 250 meter per second to keep it in position. The number of bullets fired per second by the machine is. Okay, see, we'll do similar questions, very similar questions like this. So, in order to make sure that we acquire speed in doing, first we'll try to understand this question in a subjective way, right? And then the coming questions, we shall improve our speed of solving problems, keeping this as a reference. So this question we'll try to clear it, try to solve it in a very clear subjective way. So what is given to us? Mass of bullet, which is 10 gram, right? So mass of bullet is given to us 10 gram, which is 10 into 10 to the power minus 3 kilogram. What is initial velocity of bullet? It is 0. What is final velocity of bullet? It launches out at 250 meter per second. So what is change in velocity of bullet? It is the final velocity minus the initial velocity. So delta V of bullet is actually final velocity, which is 255, minus initial velocity, which is 0. So 250 minus 0. See, now what we'll do is to get much clarity on the question, I'm gonna use one extra term here. So what we'll do is we'll say that mass of one bullet is equal to 10 into 10 to the power minus 3 kilogram. Initial velocity of one bullet is 0. Final velocity of one bullet is 0. Therefore, change in velocity of one bullet is this. And therefore, delta V of one bullet is 250 meter per second. And by impulse theorem, delta P of one, when I say impulse theorem, impulse momentum theorem, delta P of one bullet is equal to m into delta V of one bullet. If that is the case, then we can say that delta P of x bullets would be equal to x into delta P of one bullet. Straightforward, unitary method, right? If one pen costs 2 rupees, then 2 pen will cost 2 into cost of 1 pen. Simple, that logic, right? Now let us assume that the number of bullets fired in 1 second be x. Let the number of bullets be fired in 1 second be x. In which case, what would be delta P of x bullets be? That will be equal to x into delta P of one bullet, right? Now, what is delta P of one bullet? Delta P of one bullet is equal to mass into delta V of one bullet, which is 10 into 10 to the mass of bullet into delta V of one bullet, 10 into 10 to the power minus 3 kilogram into 250 meter per second, which is equal to 10 into 10 to the power minus 2 into 250 into kilogram meter per second. So this is into 250 into 10 to the power minus 2 kilogram meter per second. Okay. Now having said this, Let us write down, okay, now let us not use n here because you may get confused with Newton, which would cause much confusion. Okay, so delta P of x bullets is equal to x into 250 into 10 to the power minus 2 kilogram meter per second. Now see, what is impulse is equal to? Impulse by impulse momentum theorem is impulse is change in momentum and is at the same time is equal to f into delta t, right? So impulse can also be written as f into delta t, and therefore impulse by time is equal, well, my bad, we can say that p is equal to f into t, and therefore p by t is equal to f. So instead of f bullets, f of x bullets, instead of p of x bullets. So now we have f of x bullets is equal to delta p of x bullets by t. And what is the time here? The time here is 1 second. So if the number of bullets fired, say, is equal to x, then f bullets in 1 second will be equal to delta p of one bullet into x the whole upon t. And what is t here? T is equal to 1 second. So let us see. What is delta p of x bullets? Delta p of x bullets is from here x into 250 into 10 to the power minus 2 into kilogram meter per second. Now the whole here is time is per second, and according to the question, it is the force here is given to us as 125 Newton. So if we bring that value here, 125 Newton instead of Newton, I'll write it as 125 into what is 1 Newton? 1 kilogram meter per second square, right? See, now units make sense. Kilogram by kilogram is 1, meter per second square, second is second square, meter per second square cancels. Now all what we get is 125 is equal to x into 250 times 10 to the power minus 2. Therefore 125 by 250 into 10 to the power minus 2 is equal to x, right? And therefore x is equal to 12500 by 250. So what we get is x is equal to 50. Therefore the number of bullets fired is equal to 50. See, this is the, I would say, the subject way, the elaborate way to understand the question. In the coming questions, we won't do in this detail. We just skip the basic steps and try moving, try to do the questions faster. Body of mass 500 grams moves along x-axis such that its velocity varies with the displacement x equal to x with x, according to time with the relation v is equal to 10 root x. The force acting on the body is, okay. So this is a very straightforward question. To visualize the given question here, so we have origin here. So assuming this to be the origin, x-axis, an object is present here. The mass is 500 gram. So which is 500 into 10 to the power minus 3 kilogram, right? Okay, so what is given to us? See, what is given to us, v is equal to 10 root x, right? So in order to eliminate root, let me just write it down here. In order to eliminate the root, so eliminating the square root will always make the calculation go easy. So we have v square is equal to 10 root x the whole square, right? So v square will be equal to 10 root x the whole square, which will be equal to 10 square into root x the whole square, which is 100 into root x the whole square is x. Now, if we differentiating this equation with respect to x, what do we get? Derivative of 2 square will be 2v dv, 100 would be dx. 100x would be 100 dx. Now, if we bring dx to the other side, to the LHS, so what we get is 2v into dv by dx is equal to 100, and therefore we can say that v into dv by dx is equal to 100 by 2, which actually is equal to 50, right? Now, what is f is equal to? See, f is equal to ma. What is a is equal to dv by dt? Now this A is equal to dv by dt. I'm going to write this as m into dv into, sorry, m into dv by dt, right? And instead of dv by dt, I'll fill these places as dx by dx. In which case, what is dx by dt? Dx by dt is v, and what is dv by dx? It remains dv by dx as such. Therefore, what is f is equal to m into v into dv by dx, right? Now, therefore, f is equal to, what is m? The mass of the body is 500 into 10 to the power minus 3 kilogram into what is v? V is given to us as, let us go to the question again, 10 root x, right? So we found it as 50. So this can be written as v, wait, not v is not 50. V into dv by dx is 50. Therefore, we can write this as into 50. Therefore, force is equal to 500 into 25 newtons, right? Okay, so very simple, straightforward question. At any instant, the velocity of a particle of mass 500 gram is 2ti cap plus 3t square. If the force is at t equal to 1 second is I plus xj, then okay. So what are we given? We've been given velocity, we've been given mass, and we've been given time and force. So which equation can you make use of? So F is equal to ma, right? Yes. See, m is given as 500 gram or 510 to the power minus 3, or to be very simple, m is equal to 1 by 2 kilogram, right? See, velocity is given to us as 2t I cap plus 3t square j cap. Force is given to us as 1 I cap plus xj. Instead of xj, not to make sure that we don't make any mistake, instead of x I've written as y here, y j cap. That doesn't matter actually. So F is ma. What is A? A is dv by dt. So we have F is equal to m into dv by dt. So we have 1i plus y j cap is equal to m into dv by dt, so which is d by dt of v. V is 2ti plus 3t square j, 2ti plus 3t square j. So if we differentiate this, what we get is, what is m? M is 1 by 2 into d by dt of 2ti cap is 2i cap, right? Plus, okay, let me not skip steps here. So what is d by dt of 2t? It is 2 into t to the power 1 minus 1, which is 2 into t to the power 0, which is 2, right? And what is d by dt of 3t square? D by dt of 3t square is 3 into 2 into t to the power 2 minus 1, which is 60, right? So we have plus 60 into j cap. So this is equal to, now we multiply this 2 into it. So what we get is 2i cap by 2 plus 6t j cap by 2, which is equal to I cap plus 3t j cap. Now what is this equal to? This is equal to 1i plus yj cap. So 1i is equal to y, yj is equal to 3tj. So these two values are equal, which means we can say that yj cap can be compared with 3tj cap, and therefore we can say that y is equal to 3t, and at t is equal to 1, this becomes y is equal to 3 into 1, which is equal to 3. Therefore the correct value will be y is equal to 3, or according to the question, x is equal to 3. Figures A, B, and C and D show variation of force with time. Oh, I'm sorry. I'm sorry. The complete question is not here. I'm sorry. So this actually asked for the highest impulse. Which among the following graphs shows the highest? Which among the following graphs shows the highest impulse is the question here. So we know what is the concept here. The concept is that area under the forced time graph, is actually impulse, right? So impulse actually forced area under the forced time graph. What does it mean? It means that if you have a graph like this, and this is force, this is time, being y and x axis respectively, then the area under this graph, will totally give you the value of, what? Will give you the value of impulse, right? So impulse I or J is equal to m dot t, and this also is equal to change in momentum. Okay. Now, having understood the basic, we can now start solving the question. So let us do it one by one. So this is figure A, right? Figure A. And where is the area? The area which we are talking about is this area, this triangle area. So in figure A, impulse in figure A is actually equal to area under triangle, which will be equal to half into base into height. So say if I were to mark so this is O, A, B, and say this is the height C, then I can write that area is half into OB into AC, which is equal to half into, what is measure of OB? OB is 1.0, so it is 1 into AC is 0.5, so it's half, 1 by 2 is 0.5, so 0.5 into 0.5, which is 0.25. So we got IA is 0.25. Now let us see what do we have for P. So for B, if we were to find, this as the given area, right? This is the area, in which case this rectangle is the given area. So would be more simple here. I in B would be equal to length into breadth. So this is the length, right? The breadth. So what we have is 2.0 into 0.5, which is 1. Now for this triangle here, right? For this triangle here, the area in the graph is this area. Again, what we get is IC is equal to, right? Area under the triangle is equal to half into, what is the base? Now this becomes really, really basic. 1.2 into 0.75. So IC is equal to half into 0.75, right? Yeah. So what we get is 0.5 into 0.75, and therefore IC is equal to, so what is 0.5 into 0.75? 375, right? So we have 0.375. And now coming to the final one, which is T, when we bring it over here, again what we have is a rectangle, right? And this time the area of the rectangle will give us ID. So what is ID? Impulse under D is length into breadth, so which is 2 into 0.5, which is equal to 1. So if we are to analyze the regions here, okay, so I think I have made some mistake in drawing the graph here. Might be a mistake that came up during copying down the question. So B and D actually, sorry, B and D are the same figures here. There's some minor mistake. Well, within this data, I think the correct answer is B or D. Okay, so within this, a minor mistake anyway. But see, the point is that you understand the concept of the question, which is clear, is what I believe. Okay, so yeah, so having said that, let's do the next question, which is a repetition of question number 1. What we did: machine gun of mass 10 kilogram fires 20 grams. A machine gun of mass 10 kilogram fires 20 gram bullets at the Okay, it's at the so this is the question. See, there are some questions in the series which may not be complete and which may not have all the options as well. So I'm sorry for that. Now with a speed of 100 meter per second each, and this actually I think the recoil velocity is the question. The recoil velocity of the gun is. The recoil velocity is the question. Okay, so so first let us write down what all things are given to us. So a machine gun of mass 10 kilogram fires 20. So we'll say mass of gun is 10 kilogram. Mass of gun is 10 kilogram. Mass of bullet is 20 grams. So we'll convert it right here. So 20 into 10 to the power minus 3 kilogram. Number of bullets in 1 second. So it's given that 180 bullets per minute, right? So it is 180 bullets. 180 bullets per 180 bullets per minute. How much this will be equal to? This will be equal to 180 bullets. How much is 1 minute? So this is 1 minute. So 1 minute is 60 seconds. So which gives us 3 bullets, right? 3 bullets per second, right? So we have 3 bullets per second. Okay. Now, if we have 3 bullets per second, number of bullets in 1 second is equal to 3. Initial velocity of bullet is 0 and final velocity of bullet is given to us as 100 meter per second. Now let us try to visualize the concept one more time. So I think the question number 1 on this series was again based on the same concept. So for those who are watching it online, I'll put a link somewhere over here in the video, which will help you to going back to the question. It's a similar question. See, practice similar questions will make your confidence boost, right? Okay. So what we have here is the system. Here, what we consider is to be the bullet and the gun, right? So what is the system? The system is this complete system. Will comprise of, so what is this dotted line represent? This dotted line represents the system. And what is the system comprises of? It comprises of gun and the bullet. So now we consider the system before and after firing. So before and after firing, if we assume this to be the system, we can say that there is no external force acting on it, right? There is no external force acting on it. So all the forces that is causing the bullet to act is actually coming due to the gun, actually due to the chemical reaction, but it is coming within the system and not due to any other external agent, right? No external agent is acting on it. All of the motion within the system is taking place due to the forces which are acting within the system, right? Within the system, not external. Okay. Since there is no external force acting on it, we can say that change in momentum is equal to 0. And if change in momentum is equal to 0, it means that momentum is a constant, and therefore initial momentum should be equal to final momentum. Now, initial momentum will have 2 components. 1, the bullet. 2, the gun. Final momentum will have 2 components. 1, the bullet, and 2, the gun. Okay. So I hope this much is clear. That concept is clear. Let us now try to make it in a mathematical way. So this is the system. Okay, now see. Now this is understood. We don't need to draw the system every time, right? So this is a system here. And in this system, the initial momentum has 2 components. One of the gun and the second of the bullet. So what's momentum? Mass into velocity. Mass of gun into initial velocity of gun plus mass of bullet into initial velocity of bullet. Now, initial velocity of bullet and initial velocity of gun is 0 because both of them are at rest, and therefore mg into ug will be mg into 0 plus mb into 0, and therefore these two terms become 0 plus 0. Now, coming to the final position after firing. So after firing, the system still remains the same. The bullet and the block is the system, right? Bullet and the block is the system. And when bullet and the block is the system, what we have is final velocity is Vb for the bullet and final velocity for the gun is Vg, and it is this Vg what we call as the recoil velocity. So we can write here that mg_vg plus mb_vb, and if we transpose mb_vb to the RHS, what we get is mg_vg will be actually, so I just skipped one step. Maybe I should write down that also. So we have mg into vg minus mg into vg is equal to mb into vb, and therefore we have vg is equal to mb by mg into vb. This minus represents that the velocity, since we say it is velocity and not speed, we say that velocity is in the opposite direction, right? Velocity is in the opposite direction, and it is this minus vg what we call as the recoil velocity, right? Recoil velocity of the gun. Now, one specific thing that we need to understand here is, see, this complete set of mathematical equations what we write is in terms of 1 second. It is meter per second. So every calculation is based on 1 second. So rate of momentum in 1 second is what we do. But according to the question, in 1 second, how many bullets are fired? In 1 second, 3 bullets are fired. So ideally what we should be doing is, instead of 3 MB, we should be writing here, sorry, instead of MBVB, we should be writing 3 MBVB. Okay, let me just take one more minute to explain you, to make clear that concept. See, what we have here is 1 second, we have 3 bullets, right? So what is momentum of 1 bullet? It is mass into velocity. So what will be momentum of 3 bullets? It will be 3 into momentum of 1 bullet, which is 3 MB. Maybe one more time. What is final momentum of 1 bullet? It is MV. In this case, it should be, what is mass of the bullet? It is 20 into 10 to the power minus 3 kilogram into, what is velocity? Velocity is 100 meter per second. In which case, what will be final momentum of 3 bullets? It will be 3 into final momentum of 1 bullet, which will be 3 into this value. So we have 3 into 20 into 10 to the power minus 3 into 100 into kilogram meter per second, right? So this is the final momentum. This is 3 into 20 into 10 to the power minus 3 into 100. Now, why is this? Because in 1 second, it's not 1 bullet being fired. We have 1 second, 3 bullets are being fired. So that's how the equation gets modified here. I hope that concept is clear. So now let us go back to the equation. Okay, so now we can write that minus Vg is equal to, what is mass of bullet? Mass of bullet is given to us as 20 grams, right? So it is 20 into 10 to the power. Okay, now there's 3 missing here, right? So there will be 3 here. Okay. So we have 3 into 20 into 10 to the power minus 3 into, what is velocity of bullet? It is 100 meter per second. The whole divided by, what is mass of gun? Mass of gun is given to us as 10 kilograms. So now you may be wondering, what about the units? We will see that. So this is kilogram into meter per second, and therefore kilogram will cancel. The final equation will be in terms of meter per second, which is velocity. So that equation is dimensionally consistent. So now all we need to do is solve the equation. So what we get is minus Vg is equal to 3 into 2. Okay, now say 10 by 10 is 1, 3 into 2 is 6, 6 into 10 to the power minus 3 into 10 to the power plus 2. Therefore, minus Vg is 6 into 10 to the power minus 1, or otherwise minus Vg is 6 by 10, which is 0.6 meter per second. Therefore, the recoil velocity of the gun is equal to 0.6 meter per second. Is the concept. Force acts for 20 seconds on a body of mass 20 kilograms starting from rest, after which the force ceases, and then the body describes 50 meters, and in the next 10 seconds the value of force will be. So this is very important to understand, or to visualize the given scenario here. So given to us that mass is 20 kilogram. For the second half, 10 seconds, the distance covered is 50 meter. U is 0 because it is starting from rest. Now, to have a better clarity in the, I would say, to have a better clarity on the diagrammatic side, what we'll do is we'll consider this diagram here. So this represents motion of a body from A to B, which actually takes place in 20 seconds, the first 20 seconds, and then the force ceases to act. Therefore, we have B to C for 10 seconds. Okay, so the first half is, if I were to write this half is actually uniformly accelerated. Why? Because it is under the presence of a external force. This force ceases to exist here, which means from here it is gonna be in a uniform velocity. Why? Simple logic, because friction is not present here. Nothing being said about friction. So in the absence of friction, a body will continue to be in the state of uniform motion unless and until invoked by a external force. So there is no external force acting and the velocity is vb, therefore it will keep on acting like this. It will keep on traveling with the same velocity, which means actually vc is equal to vb, right? Okay, so it was u, gradually the velocity increases to vb, force is no longer acting, therefore the velocity stays constant, right? So the first part is only for 20 seconds. For the motion along AB, u is equal to 0. Velocity at B, VB, velocity at B is VB, which is something we don't know. So for the motion along AB, for that equation of motion, V is equal to u plus AT, A is equal to V minus u by T. Now what is this V? This is VB, right? Now what is T here? T here is equal to 20 seconds. Therefore we can write this is equal to VB minus, right? This can be written as VB minus 0 by 20, which is equal to VB by 20. Now, for the next half, for the motion along BC, initial velocity is VB, final velocity is also VB, which means acceleration is 0. This term vanishes, right? This term is no longer present. So when that term is no longer present, we can say that, I'll repeat it, initial velocity is equal to final velocity. So VB is equal to VC, and therefore we can say that acceleration is equal to 0. Now all what we have is the 10-second motion, right? The 10-second motion, displacement is 50 meter. Therefore we can say that in 10 seconds the displacement is 50 meter. If rest is equal to VB into T. Therefore VB, what we get is 5 is equal to VB. And if 5 is equal to BB, what can we write? F is equal to MA. F is equal to MA. So this will become mass is 20 kilogram. So 20 kilogram into acceleration, which is acceleration is VB by 20. So write it one more time here. Acceleration is VB upon 20. So this is further equal to 20 by 20 is 1. So this is equal to the value of VB, which is, okay, so it is 20 into VB by 20, 20 by 21, what is VB, which is equal to 5, and therefore the value of force is 5 newtons. In two different experiments, an object of mass 5 kilogram moving with a speed of 25 meter per second hits two different walls and comes to rest within. Okay, so first is within 3 seconds, second is within 5 seconds. Choose the correct option of the following. Impulse and average force drag will be the same. We will say both cases. Impulse will be same, but average force will be different. Average force will be same. Okay. So first we'll try to visualize this and then try to understand what the concept is. So we have two cases here, case 1 and case 2. Case 1 is 5 kilogram mass. Case 2 is also 5 kilogram mass. Same velocity, right? Speed of 25 meter per second, 25 meter per second, 25 meter per second. Hitting wall 1, hitting wall 2. Okay. First, let us think. Let's first try to solve the impulse part. See, we know that by impulse momentum theorem, right? By impulse momentum theorem, what is impulse is equal to? Impulse is equal to change into momentum, which is otherwise equal to the force average into the change in time. So impulse is change in momentum, which is also equal to F average into delta T. Now what is change in momentum? Change in momentum is mass into change in velocity, which is final velocity minus initial velocity. Now according to the question, it comes to rest, right? It comes to rest. Therefore, the final velocity should be equal to 0, which means the object actually when it comes here, it comes to rest. So the final velocity is equal to 0. The object comes here, it comes to rest, final velocity equal to 0. And in both cases, the initial velocity is 25 meter per second. So Let us call the second case impulse as delta P1. So what is delta P1? Change in momentum as delta P1. So what is delta P1? Delta P1 is mass into 5 into final velocity 0 minus 25, right? 0 minus 25. What is delta P2? Case 2. What is mass? 5 kilogram. What is final velocity? 0. What is initial velocity? 25. So what we get is delta P2 is also 5 into 0 minus 25, which simply gives us the value that delta P1 is equal to delta P2, or in other words, impulse 1 is equal to impulse 2, right? I hope this much is clear. Now let us try to see the force part. So what is delta P1? We know that delta P1 is force average into delta T1. What is delta P2? Force average into delta T2. Let us divide these two equations. Dividing 1 and 2. Or maybe you can equate 1 and 2 as well, because both of them are equal. What we get is force average into delta T1 by force average 2 into delta T2 is equal to delta P1 upon delta P2. But we just derived that delta P1 is equal to delta P2, and therefore this should be equal to 1, which implies that force average 1 by force average 2 is equal to delta T2 upon delta T1. What is delta T2? Given the question that delta T2 is 5 seconds, so this is 5 upon delta T1 is 3 seconds, so this is 5 upon 3, right? So we can say that force average 1 is actually equal to force average 2 into 5 by 3, which would be, so we can say that force average 1 is force average 2 into 5 by 3. So what is 5 by 3? 5 by 3 is say 1.6. Therefore it means that the average force in first case is actually 1.6 times the average force in second case. Therefore force average 1 is actually greater than average force 2. So the conclusion is impulse in first case is equal to impulse in second case, whereas force in first case is greater than force in second case. A balloon has a mass of 10 gram in air. The air escapes from the balloon at a uniform rate with a velocity 4.5 centimeter per second. If the balloon shrinks in 5 seconds completely, then the average force acting on that balloon will be, okay, in time. Okay. So if we were to visualize this, this question here. So this is a balloon here of mass 10 gram. It's going up, and the velocity is the velocity with which the air is escaping is 4.5 centimeter per second. And as it moves off, we know that since air is escaping, the mass of the balloon will reduce, and eventually it becomes 0. And this complete transition from 10 gram to 0 gram takes place in t is equal to 5 seconds. So the mathematical form to understand this is that F is equal to dp by dt, right? Which is equal to d by dt of mv. So this is m into dv by dt plus v into dm by dt. So basically F is equal to m into dv by dt plus v into dm by dt. This is what we have as equation. Now from this question here, it is given that the velocity is 4.5 centimeter per second, which means velocity is a constant, and when velocity is a constant, dv by dt is equal to 0. Therefore this term here vanishes, which means what we get is F is equal to v into dm by dt. Therefore F is equal to, what is v? Velocity is 4.5 centimeter per second into, what is dm by dt? Change is 10 to 0, right? So dm is equal to 10, and what is dt? This is taking place in 5 seconds, so dt is 5 seconds. Therefore this is 10, what is the unit? 10 gram per second. Now why am I emphasizing on unit this much? Is because of the fact that it is asked in time. So F becomes 4.5 into time is 5 seconds, right? So it is 5 seconds. So 10 by 5 is 2 into gram centimeter per second into second is second. So gram centimeter per second square. So what we get is F is equal to 9 gram centimeter per second square. And what is gram centimeter per second square? See, one dyne is actually equal to 10 to the power minus 5 Newton, and one dyne is also 1 gram when accelerated through a acceleration of 1 centimeter per second square. So this actually becomes F is equal to 9. What is gram centimeter per second square? It becomes Newton, right? Sorry, it becomes dyne. So the correct option is force is equal to 9 dynes. Ball of mass 0.15 kilogram hits the wall with its initial speed of 12 meter per second and bounces back without changing its initial speed. If the force applied by the wall on the ball during the contact is 100 Newton, calculate the time duration of contact of ball with the wall. First, let us visualize this and then we'll try to find the solution. Okay, so this is what's given to us in the question. So we have a wall, right, and a ball is hitting the wall, and then it is bouncing back. So this is what happens when the ball is hitting the wall and then the ball is bouncing back. So it is given that the speed doesn't change, right? Speed doesn't change, which means there is a change in the direction but not in the speed. So what is the speed? The speed is given to us as 12 meter per second, and the speed is also given to us as 12 meter per second. Now, to not to use vector approach, we just use the sign here. So since it is moving towards left, what I'll do is I'll take this as negative, and since it's moving towards right, I'll take this as positive. So this is the reference tag that I've chosen. Towards is right, and motion towards right is positive, and motion towards left is negative. Okay, so what does this mean? This means that initial velocity u is minus 12 meter per second and final velocity v is 12 meter per second. So now let us write down things. So what is mass is equal to? Mass is equal to 0.15 kilogram. What is initial velocity? U is equal to minus 12 meter per second. What is v is equal to? V is plus 12 meter per second. What is F is equal to? F is given to us as 100 Newton. F is given to us as 100 Newton. Okay, and we know that force into time is, right? Force into time is change in momentum. So we can write that force into time, or say force into delta time, force into change in time is equal to change in momentum. Now what is change in momentum? Change in momentum is m into delta v, which is m into v minus u, final minus initial. What is the final velocity? The final velocity is 12 meter per second. So this is 12 minus, what is the initial velocity? Initial velocity is minus 12 meter per second. So this is 12 minus 12. So what we get is m into 24 is equal to, what is F? The value of F is 100 Newton, right? So this is 100 into delta t. So I'll just write down things over here. Yeah, okay. So now what we have is 100 into delta t, right? 100 into delta t is equal to m into, what is m? M is 0.15. I'll write it as 15 by 100. So it's 15 by 100 into delta v is 24. So this is 24. So what is the value of delta t? So delta t is now is equal to 15 into 24 the whole upon 100 into 100. This is equal to, what is 15 24? Okay, so it is 3. Let's calculate it. So 15 into 24 is 5, 4, 16, right? 52 are 30. So it is 360. Okay, so we have 360 upon 1,000,040 zeros. So what we get is 36 by 1000, which is otherwise 0.036. So delta t is 0.036 seconds. A man of 60 kilogram is running on the road and suddenly jumps into a stationary trolley car of mass 120 kilogram. Then the trolley car starts moving with the velocity 2 meter per second. The velocity of the running man was when he jumps into the car. Okay, so a man of running. Okay, so let us first visualize the given condition. So let us assume that this is the man trolley, right? So the man initial velocity is u1 and the initial velocity of trolley is u2. 60 kilogram weight for the man, 120 for the trolley car. Yes, okay, trolley is 120. The trolley car starts moving with velocity 2 meter per second. It starts moving with the velocity equal to 2 meter per second. A man of 60 running on the road and suddenly, okay, so this man here, he jumps to the trolley and okay, it's a stationary trolley car, which means this velocity is equal to 0. So a stationary trolley, a man jumps it with the velocity he's running, and he jumps into this trolley, and the trolley starts moving at the speed of 2 meter per second. Now when it starts to move, we know that both the masses can be combined together and both of them will have the same velocity, that is 2 meter per second. So what we need to understand here is that when it starts to move, basically what happens is this is one complete system. Actually, this is 180 kilogram mass moving with 2 meter per second velocity, right? So see, these kind of questions from the practice that we have done so far, the moment we see this question, we should be able to understand that this is nothing but conservation of linear momentum, which means we need first to identify the system. Now, how do we identify that this is linear momentum? Simple, m1 u1 m2 u2, which simply gives us a correlation that we need to find. We start doing this in linear momentum, conservation of linear momentum. So system is man and trolley. Now, since there is no okay, wait, let me just write down the basic. If external acting on this system, when I say system, it means the man and the trolley. Since this complete motion of this man and trolley is influenced only by the forces acting between these two, therefore we can say that since F external is equal to 0, change in momentum should be equal to 0, and if change in momentum is equal to 0, it implies that the final momentum should be equal to the initial momentum. Now, what is the final momentum? The final momentum means, after this condition, right? So the final momentum means mass into final mass into final velocity. What is the final velocity? 2 meter per second. What is the final mass? It is m1 plus m2. So basically this here represents the final momentum and this represents the initial momentum. Now, what is the initial momentum? This condition over here. So this represents the initial conditions, and this part, the second part over here, represents the final condition. And in the initial condition, there are two different masses, m1 u1 and m2 u2. So we have m1 u1 plus m2 u2. Now u2 is equal to 0, so we can write that this term, okay, this term gets eliminated. So what is there? m1 u1. What is m1? m1 is 60 kilogram. What is u1? We don't know. So 60 kilogram u1 is equal to m1 plus m2. So m1 plus m2 here is 60 plus 120. So m1 plus m2 is 180. So this becomes 180 into v. V is the common velocity by which both the man and trolley as a system moves, which is given to us as 2 meter per second. So this is into 2, and therefore u1 is equal to 180 into 360 upon 60, which is equal to 6 meter per second. Which means that the man was running with the velocity of the man was 6 meter per second. A block of mass 2 kg moving on a horizontal surface with a speed of 4 meter per second enters a rough surface ranging from x equal to 0.5 meter to x equal to 1.5 meter. The retarding force in this range of rough surface is related to distance by F is equal to minus kx, where k is equal to 12 Newton per meter. The speed of the block as it just crosses the surface will be. Okay, so let's first visualize the question. So according to the question, we have a mass here which is moving with a velocity of 4 meter per second. So it's smooth body, it's moving over a smooth surface, and then it encounters a rough surface wherein the motion is retarded and the velocity should of course gradually decrease, and it would come to some value over here, right? Okay, so the question is, how do we approach the solution? See, so what we need to understand here is, what are we given? We've been given x1, which is equal to 0.5. We've been given x2, which is also equal to 1.5. which means we can find out delta x, which is nothing but x2 minus x1, which is okay, whatever. So now we're also being given f, which is equal to minus kx. The moment you see delta x and f, what should come into your mind? Work done by this force, retarding force, will be equal to, say, call this f retarding, will be equal to f retarded dot delta x, right? Because work is force and displacement, and the velocity here is u is equal to 4 meter per second, and the velocity over here is something that we need to find out. So let's call this v. So we also know that work done is otherwise equal to change in kinetic energy. Straightforward. So you can do this as half m into v square minus u square, and you have an answer for that. But that's one way of looking at the question. Now another way, I mean, this would help you. This kind of understanding will help you in solve the question for the actual exam, where you are not being asked to solve a question from a specific chapter. Instead, you'll be asked to find the correct answer. But here, what we'll do is we'll try to cover this using Newton's laws of motion. Okay. For that, what I'll do is f is equal to ma. Now what is f here? F is fr, and what is fr is equal to? Fr is equal to minus kx, which means we can take that ma is equal to minus kx, and a is dv by dt. Now see, we have already discussed how does this come, but we just make it this one more time. So what is a is equal to? A is equal to dv by dt. Now instead of dv by dt, can I write this as dv into 1 by dt, and then right here dv by dx into dx by dt, right? Therefore this a is equal to, so what is dx by dt? Dx by dt is v, and this becomes v into dv upon dx, and therefore we can write that this is m into v into, right, m into v into dv upon dx is equal to minus kx. What next? So we can write this further as m into v into dv is equal to minus kx into dx. Okay. So now this is in the variable separable form. This is in the variable separable form, and thus can be integrated. So if we, okay, maybe just we'll write it one more time. So we can write this as mv into dv is equal to minus k into x into dx, and now this can be integrated. And now when we integrate, we need the lower limit and the upper limit. So lower limit for the x is very clear here, 0.5 to 0.5, upper limit is 1.5. So we can write over here. So this becomes 0.5 to 1.5. And for the velocity, the lower velocity is u, right? Lower velocity is u to v. U is given to us as 4 meter per second, and we have to find out v. Now this becomes m into integral of v is v square by 2 varying from 4 meter per second to v meter per second is equal to, thus giving you the change in kinetic energy, minus k into integral of x is x square upon 2 varying from 0.5 to 1.5. So this gives you further, what's the value of m? The value of m is 2 kilograms. So 2 into v square by 2 minus 4 square by 2 is equal to minus k into x square is 1.5 the whole square divided by 2 minus 0.5 the whole square divided by 2, right? Okay, so what is the value of k? The value of k is given to us as 12. Okay, so the value of k is given to us as 12 Newton per meter. Okay, so which means if we do the further calculation, what we get is 2 into v square by 2 minus, okay, I'm not going to cancel the 2 here, let it be there. So 16 by 2 is equal to minus k into 1.5 square minus 0.5 square. I'll cancel out 2 from the whole fraction here, so do the whole equation here. So what do we get? What we get is 2 into, instead of k we can write here 12, right? Instead of k we can write here 12. So this becomes 2 into v square minus 16 is equal to 12 into 1.5 square minus 1.5 square minus 0.5 square, right? So this is further, this is v square minus 16 is equal to, wait, is there any other way of solving this? Are we doing it in the difficult way? Well, okay. So this 12 by 2 is 6. 6 into 1.5 square minus a square minus b square is a plus b, which is 1.5 into 0.5, which is 2. And a minus b, 1.5 minus 1.5 minus 0.5. So this becomes into 2. So v square is equal to 6 into 2 is 12. 16 plus 12 is, wait, a plus b into a minus b. 1.5 plus 0.5 is 2. 1.5 minus 0.5 is 5 is over 2. So 6 into 2 is 12. We did a small mistake here. There is a minus symbol here, right? Yeah, this is minus over here. Okay. So now what is v square minus 16 is equal to minus 12, and therefore v square is equal to 16 minus 12, and v square is equal to 4, which gives us v is equal to 2 meter per second. Therefore, the correct answer here is that the speed of the block as it just crosses is v is equal to 2 meter per second. A batsman hits back a ball of mass 0.4 kilograms straight in the direction of the bowler without changing his initial speed of 15 meter per second. The impulse imparted to the ball. Okay, so the moment we see impulse, we can directly say that the formula to be used is I is equal to F delta T, and which is equal to M in delta V. Now, if we were to visualize this given scenario here, so this is the bat, assume this to be the bat, and this is the ball. Now, the ball is approaching the bat straight in the direction of the bowler without changing, which means it goes exactly like this without changing its initial speed. Now the speed is not changed, but the direction is changed. This means that the velocity will change, right? So if we take those values towards the right as positive, we'll have to take towards the left as negative. So initial velocity u will be equal to plus 15 meter per second. Final velocity v will be equal to, towards the left means minus 15 meter per second. Okay, well, of course, so we can say that I is equal to m delta v. So v is minus 15, u is again minus plus 15. Mass of the ball is 0.4 kilograms, so this is 0.4 kilogram into minus 30, which gives us 1.2 as the impulse. Or, oh sorry, not 1.2, 0.4 to 30 is 1 point, not 1.2, it is 12. So this becomes 12 kilogram meter per second, which is otherwise 12 Newton second, right? So impulse is 12 Newton, so the impulse imparted to the ball is 12 Newton second. An object of mass 5 kg is thrown vertically upwards from the ground. The air resistance produces a constant retarding force of 10 Newton throughout the motion. The ratio of time of ascent to the time of descent will be equal to. If we were to visualize the question here, visualize the given data here, this is what's been represented. An object of mass 5 is thrown from vertically upwards from the ground. So say this is the ground. This is the ground. It is thrown from A. It reaches B. Okay, and this is what I've been represented here, from A to B, ascent. Okay, and then during descent we have the motion from B to A. So this is here represented as descent B to A. So from A to B, there is some initial velocity, and the final velocity we know as the object reaches its top, it is going to be equal to 0, right? For the descent, the initial velocity will be the final velocity of ascent. I repeat, for the descent, initial velocity of descent will be the final velocity of ascent. Final velocity of ascent is 0, and therefore descent would be, the initial velocity of descent would be 0. It will keep on increasing. Why? because acceleration due to gravity will have an accelerating effect here, and therefore it will increase and reach with the velocity v and hit back the ground again. As it is moving upward, g will have a negative effect, it will have a decelerating effect, and as it's moving downward, the g will be having a positive effect here. Okay, so I hope this much is clear. Now let us see what these two diagrams represent. See, this represents the two different accelerations acting on the body. We have two different accelerations. One is due to acceleration due to gravity, which is ag. Other is acceleration which is produced by the air resistance. Okay. Now, how do we visualize this? How do we visualize it even better? So if we were to use the concept of loss of free body diagram here, if I take an object, assume this to be the object here. I think it's better that we take these cases individually, and things will become more clear to you. So as of now, let's just try to understand this. During the ascent, the acceleration due to ascent will be equal to minus ag minus ar, which is equal to minus of ag plus ar. What is ar? Acceleration due to the resistive force, or maybe we could write air resistance, right? Yeah, so okay, ar, acceleration due to resistance. And during the descent, it would be acceleration due to gravity plus acceleration due to gravity minus acceleration due to resistance. Okay, so that's going to be the difference here in terms of acceleration. How did we come to it? We'll take both these cases individually. We'll use free body diagram to understand what are the various forces acting, and then we'll come to a conclusion. So now let us first draw the free body diagram of this block during the motion from A to B. Okay, so during that motion, this object is moving upwards, which means the net direction of motion is actually acting upwards, right? Okay. Now, what are the other forces acting on it? We've been given that there are two forces. One is the air resistance, which means the force of air resistance is acting on it along with the weight of the body, right? So there are only two forces being acting on this, and the net direction of velocity is acting upwards. Now, how do we approach this how the equation? We say that sigma Fy is equal to m into Ay. Now, what is sigma Fy? Sum of the forces acting in the y direction. How many forces are there? There are two forces, W and Fr. How do we take the sign convention? See, we always assume all the forces in the direction of motion to be as positive. Since the object is moving upwards, the direction towards upwards is positive, and therefore all other forces acting downwards would be taken as negative. So sigma Fr would be minus W, sigma Fy would be minus W minus Fr is equal to m into Ay. Now what is Fr? Fr is force acting on the body due to the air resistance. That will be equal to mass into acceleration acting on the body due to air resistance, right? In which case I can write this as minus W minus Fr is equal to m into Ay. What is weight? Weight is minus mg, so this becomes minus mg minus mr is equal to may. If I cancel out m from all terms, what I get is minus g minus ar is equal to ay during ascent, right? Ay during ascent. So I hope this much is clear. Now, Fr is equal to m into ar. Okay, straightforward equation. What is Fr? Fr is given to us as 10 Newton. What is the weight of the mass? Mass is given to us as 5 kilogram into ar. Therefore, what is ar? Ar is 10 by 5, which is 2 meter per second square. In which case, what is acceleration in the y direction during the ascent? Acceleration y direction during the ascent is equal to minus g, which is minus 10 minus ar, which is 2, 12. Therefore, what we have is minus 12 is equal to AY during ascent. Okay. We'll repeat the same calculations for the descent, and then things will become crystal clear to you. You'll be wondering why do I have this equation ST is equal to U2 here? We'll come to that, but not now. Now let us see for the motion along. Let us see for the motion along. For the motion along BA, which is in simple terms the descent of the body. So this is B, this is A, and now we have the object coming in the opposite direction, right? For here, let us try to draw the free body diagram. So this is the object. The weight is 5 kilogram. What are the various forces acting on it? Yes, we know definitely weight is going to pull this downwards, right? And we have the resistance. See, now here things become a bit conceptual to understand. Air resistance will oppose the motion, right? Air resistance will oppose the motion, which means direction of air resistance will be opposite to the direction of motion. Okay, direction of air resistance will be opposite to the direction of motion. What is the direction of motion? It is BA. In which case, what will be the direction of air resistance? It will be A to B, which means air resistance would be acting like this. So what is this? This represents the force of air resistance. Okay, right. Now, applying Newton's law of motion, we can say that sigma Fy is equal to m into Ay. What is sigma Fy? The direction of motion, the net direction of motion is towards downwards. Therefore, all those forces acting downwards would be taken as positive, and all those are acting upwards would be taken as negative, which means W will be positive here and Fr would be negative here. So if we write this as equation, we can say that W minus Fr is equal to m into Ay. What is W? It is mg. What is Fr? It is m into Ar, which is equal to m into Ay. And therefore, if I cancel out m from all the terms, what we get is G minus Ar is equal to Ay. What's the value of G? The value of G is 10. What's the value of Ar? We derived it to be 2, and therefore Ay. Which Ay? Ay during the descent is equal to 10 minus 2, which is 8. 10 minus 2 is equal to 8 meter per second square. So Ay during descent is 8 meter per second square. Okay. So I hope this much is clear. Now, if this idea is clear, we'll move on to the next part of the solution, wherein things may become a bit more easy to understand. Okay, so let us not skip the steps. Let us try to understand the steps in detail one more time. Okay, see. Now, for this motion, when we have E for the motion along A to B, right? For the motion along A to B, now we don't need this diagram. I can write first equation of motion as V is equal to, right? V is equal to U plus AT. Can I? Right, V is equal to U plus AT, or do we want it to write it? Okay, let us skip this equation as well. Let us skip this equation. We don't need this equation. V is equal to U plus AT. Now what is V? V is 0 from here, which means we have 0 is equal to U plus AT. What is A? Acceleration during ascent. What is T? Time of ascent. So therefore U actually becomes minus acceleration of ascent, time of ascent. U is equal to minus. What is acceleration of ascent? We have derived it here as minus 12. So this becomes minus of minus 12 into time of ascent. Therefore U is actually 12 times time of ascent. Okay. Now What is v square minus u square is equal to? It is equal to 2 into a into s. For the ascent, this is 2aa into sa. What is v? The value of v is 0 here. So this becomes 0 minus 12 time of ascent square is equal to 2 into, what is the value of a is minus 12 times sa, right? So now minus 12 over 12 is 1. So what we get is ta square by 2, or we can say ta square is equal to 2 times sa. Okay. Now, for those people who are watching it offline, I would suggest that you pause your video here and you do the rest portion, the second half of the question on your own. Things will become really clear to you. Now, for the motion along BA, we have the equation v is equal to u plus at. This time I'm going to make it write it a bit more clear. So v is actually velocity at a, u is actually velocity at b, plus a is acceleration during descent, time is time during descent, right? Now, here u is equal to 0, right? U is equal to 0, which means ub here is actually equal to 0. And therefore, what do we get va is equal to? We get va is equal to acceleration of descent into time of descent, right? Now, what is the value then? Therefore, we can say that what is va? Va would therefore be equal to, what is ad? Ad we derived by 8 into td. Now see, what is the next equation of motion we're going to use here? V square, we can use v square minus u square is equal to 2as acceleration of descent into displacement during descent, right? And what is 0? U is 0. What is VA? It is 8 times TD. So we have 8 times TD, the whole square is equal to, did I miss the square portion, the last step? Did I? Yes, I did. It's U is 12 TA, which means there should be 12 square TA square, right? So 12 square TA square is equal to 12 into TA. So this is by 12. My bad. Okay. Now, over here we have 8 into t to the whole square is equal to 2 into, what is AD? Acceleration during descent is 8 into SD. So we can write here that 64 time descent square is equal to 2 into 8 into SD. So 64 by 8 is 8. So 8 TD square is equal to 2 into SD. So we have 4 TD square is equal to 8 by 2 is 4 is equal to SD. That's one equation. And the second equation here, this becomes 12 TA square is equal to 2 SA, right? 12 square by 12 is 12. So this becomes 6 TA square is equal to SA. Now, the direction of motion, the displacement to the motion from A to B is actually B to A in the reverse direction. To be more precise, SA is actually AB. And what is SB? SB is, not SB. What is SD? Displacement descent. It is BA. What is BA otherwise? BA is equal to AB, which is otherwise equal to SA. So SD is equal to SA, which means we can equate these two equations, and therefore what we get is 6 TA square is equal to 4 TD square, or TA square upon TD square is equal to 4 by 6, and therefore TA by TD is equal to 2 by root 3, which gives us the correct option as, okay, I don't have the options here, so the correct option would be 2 is to root 3. The initial mass of a rocket is 1000 kilogram. Calculate at what rate the fuel should be burned so that the rocket is given an acceleration of 20 meters per second. The gases come out with the relative speed Okay, all right. See, this question is something which represents the class of problems which we classify as variable mass problems. As the variable mass problem, well, there can be many examples. One is the conveyor belt problem, right? The conveyor belt problem, and the other is the man or the weight dropping trolley problem, and the third one is the rocket propulsion. We'll discuss all three cases here, or as and where the question comes up. So first, let me take you through the basic terminologies of rocket propulsion. So I'll tell you what's going to happen in this discussion. We will go through the basic terminologies, okay, and then we'll apply the impulse momentum theorem, okay, and then we'll find out the application, or we'll find out the application of this concept in the question here. Okay, so basic terminologies, then impulse momentum theorem, and then the application. Now, see, if you can spend a couple of minutes here to understand what's given here, then the whole derivation process and the application would become really clear to you. Just if you spend some additional time in understanding the description here. So what I've done is a rocket is being propelled from the ground. Okay, so this actually refers to the ground level, and there is a person standing here. So he's observing all these things, and he has a camera with him. What does he has? He has a camera with him. So the rocket is going up like this. Okay, what he does is he takes two photographs. One after the launch at time t is equal to t, and the other very soon after t, but with the interval delta t. So the rocket was going like this. One photo was taken here, and the other photo was taken here. So now what we have is we have two different photos of the same rocket at two different time intervals. Time is equal to t, and time t is equal to t plus delta t. Okay. Now, assume that the initial velocity of the rocket is u0. Well, it can be 0, and it can be some definite value as well. That's something we'll discuss while we go to the numericals. Okay, so the object may have an initial velocity which is not equal to 0 or maybe equal to 0. The initial mass of the rocket is m0. So what is the initial mass of the rocket? Initial mass of the rocket actually means mass of rocket plus the unburnt fuel. Okay, now as the rocket is going up, we know that velocity of the fuel will give a additional push to the rocket, which will increase the velocity of the rocket, right? So consider two fuels here. One is represented in blue color, the other is in the red color. Okay, now when one fuel is burned completely, say for example, one fuel is burned completely, the rocket experiences a push, it is acquiring a velocity of vr. Now I have used the velocity vector here and not the magnitude. So this is velocity vector vr. Okay, so what is vr? Vr is actually the magnitude of the velocity vector vre, which means velocity of rocket with respect to earth. Okay, so what is vg? Vg is the magnitude of the velocity vector vge, which means velocity of gas with respect to earth. After some time dt, we see that the additional mass rocket, the mass has also been burnt. Okay, so say the burnt mass of the fuel is dm. The mass of this point of the rocket was m. So now we can say that the burnt fuel has reduced. So we can say that the new mass is m minus dm, right? And the velocity acquired, there will be a minor change in the velocity, which we can say that velocity of rocket plus delta v, both in the vector notation. Okay, now having said this, please go through this terminologies one more time, and take your time, take a minute or maybe a couple of minutes, go through this terminology, because the more and more you understand what these basic terminologies are, the better you will have understanding regarding the derivation, or for that matter the solving the numerical. Okay, so now what we'll do is we will try to understand those two photographs in detail. So this was the first photograph, time taken at t. The other is time at t plus delta t, this one over here. Now we will consider a system here. What is the system? The rocket plus the gases. We'll consider system here. What is the system? Rocket and the gases. So we have one system at two different points, t and t plus delta t. Velocity of the rocket here is v, the mass is m, well, it's velocity vector vr, and velocity of the rocket after some time is velocity of rocket plus delta v, both in vectors, and the released gas have velocity of vg. Okay, the mass was m, the mass of rocket here would be m minus delta m, where what is delta m? Delta m represents the gases burnt. Delta m represents the gases burnt. In which case, since the overall motion of this object is, or the system is governed only by the internal constituents here, we can say that the F external acting on this is equal to 0, and therefore by the principle of conservation of linear momentum, we can say that the final momentum is equal to initial momentum, right? Now the final momentum will definitely have two components. One will be that of the rocket and the other will be that of the gases. So the final momentum will have two components. One will be that of the rocket and the other of the gases, and so will be the initial momentum of rocket plus initial momentum of gases. This is the initial condition. In the initial condition, the rocket will have, the initial rocket will have m and vr. The gas will have zero velocity, right? So here the velocity of gases is actually equal to 0, and therefore we can say that which gas, I've taken only the red one here, which means the red is still stationary, the velocity is 0, therefore this term will become 0. Now coming to the final component, what we have is final momentum of rocket is actually mass of rocket into velocity of rocket. The final mass is m minus delta m. Velocity is vr plus delta v, plus momentum of gas is actually final momentum of gas will be equal to final mass of gas, which is delta m, into velocity of gas, which is vg plus vg. So this is the equation what we have here, right? Okay, now okay, I think there is, give me a minute. Okay, so now here we'll try to do the algebraic steps left over here. So what is m into vr? It is mvr, all of them in terms of vector notation. M in delta v is m delta v, minus delta m into vr, minus delta m vr, minus into plus again minus delta m delta v plus delta m vg is equal to mvr, all of them in vector notation. So if you observe this equation, we have two terms common on the LHS and RHS, which means that we can remove these two terms, right? And all we're left is with m delta v minus delta m vr minus delta m delta v plus delta m vg is actually equal to 0. Okay, so let me take the next set of equations. What we'll do is we'll keep this m delta v on the LHS and we'll transpose each and every other term to the RHS. So delta minus delta m becomes plus delta m vr, minus delta m delta v becomes plus delta m delta v, and delta m vg becomes minus delta m vg. See, now what I'll do is I'll divide this entire equation by delta t. And delta t, and delta t. Okay, now here comes the first level of concept here. As delta t tends to 0, we know that by the logic of maths, right? I think we have discussed this many times in motion in a straight line, this tangent, secant, how this dy by dx becomes, delta y by delta x becomes dy by dx. We discussed that many times. So delta v by delta t becomes dv by dt, delta m by delta t becomes dm by dt. Now, what we also need to understand is, as the mass burnt in delta t is negligible, time is negligible, we can say that delta m can be neglected, as delta m would be equal to 0, or will tend to 0. Okay, or we can also say that change in velocity in this time delta t is also equal to 0, or in other words, as delta t tends to 0, delta m also tends to 0, and delta v also tends to 0. Or let us say for example, say this is 0.000013 seconds, and this is equal to 0.000014, and therefore what will be delta m in delta v? That would be 0.00000, very, very, very small number. Therefore what we can do is we can neglect this entire thing over here. We can neglect this entire thing, which means we can neglect this term. We can neglect this term completely, and therefore, if we remove this term, we are left with only two terms, which is on the RHS, delta m delta t becomes dm by dt, delta m by delta t becomes dm by dt, and LHS is delta v, which becomes dv by dt. Okay, now let us focus only on these set of equations. Now, so okay, now many students find it confusing over here. So what I'm going to do is I'm going to spend a little more time to explain the basic derivations from motion in a straight line. See, relative velocity of vector A with respect to B is actually velocity of A vector minus velocity of B vector. Okay, well, not R, V. And we also know that velocity of vector A with respect to B is actually equal to minus velocity of B with respect to A, right? So these three things are very basics. I know someone who is following this at JEE Mains level would be very thorough with this, but I just wrote it because I don't know, many students would come from different backgrounds. So this concept is really important here. This step is very important. Now let us see. I'll take dm by dt common from these two terms. So we have dm by dt and Vr and Vg. So dm by dt into Vr minus Vg. Again, Vr is vector. So what is vector R minus vector G? See, vector A minus vector B is vector A with respect to B, right? So vector R minus vector G would be vector R with respect to G. All right. Now, what is vector A with respect to B is equal to? That is equal to minus vector B with respect to A. And therefore, we can say that this is actually equal to VRG, which is actually equal to negative of VGR. So, VRG is equal to negative VGR. Now, what is velocity vector, the derivative of velocity vector? That is acceleration vector. What is velocity of derivative of velocity vector? It is acceleration vector. So this term can be replaced by AR. So this is m into AR. M into AR is equal to dm by dt into minus VGR. Okay. Now what is m into AR? So if you have to understand this practically, what is velocity vector? VR is the velocity of rocket. What is AR? AR is the acceleration of rocket. So what is m into AR? It is mass into acceleration of rocket, which is actually the force acting on the rocket, and therefore we have the force acting on the rocket is equal to dm by dt into minus VGR. And since this is due to the action of the gases burned, we don't call it VR. We actually use the notation F thrust. Okay, so F thrust is what we have, dm by dt into minus Vg by VR. And all of this is in the vector notation. Now, if we try to understand this using the scalar notation, what we have is, if we take magnitude on both sides, magnitude of F thrust becomes F thrust alone, and dm by dt is magnitude, and vector minus VGR, if you take the magnitude of this vector, if you take the magnitude of minus VGR becomes VGR, and therefore F thrust is equal to dm by dt into VGR. Okay, so I hope this much is clear. Now, okay, let me explain you this concept of how to use scalar notations here, because some of you may find it convenient using the scalar notation. I'll explain you that concept as well. What is that? So a man is standing here, he is observing the gases and he is observing the rocket. All right. So when he is observing the gases here, he is observing the gases while standing on the ground. So he's observing the gases while he is standing on the ground, and therefore what he sees is velocity of gases with respect to Earth. So this is Earth. Okay, one more time. This man is observing the rocket, but where is he standing? He is standing on Earth. Therefore, what is he seeing? He is seeing velocity of rocket with respect to Earth. Okay, but if you shift the same man and put him on the rocket, then when he is observing the gases here, he is observing Let me use different color. So he's observing the gases. He's observing the gases, but where is he observing it from? He's observing it from the rocket, and therefore what he sees velocity of velocity of gases with respect to the rocket. All right. Okay. Now, what is velocity of gases with respect to rocket? It is equal to velocity of gas with respect to Earth minus velocity of rocket with respect to Earth. Now, if you understand the concept here, velocity of gases, see, any vector vector A can be written as the magnitude into its unit vector. Okay, so vector B can be written as its magnitude into its unit vector. Now, if you understand the motion of this rocket, it is going to the straight direction. It is going vertically up, right? So vertically up from Earth would be positive, and vertically down from Earth would be negative. Since it is vertically up, we'll take it as positive J. We'll take it as, oh, give me a second. We'll take it as positive J and minus J. So gas with respect to us, gas is coming downwards, so we'll take it as minus J. Rocket is going upwards, so we'll take it as plus J. And if since there is more, okay, so now if you expand the bracket here, this becomes minus Vg into J cap minus Vr into J cap. If you take minus J common, this becomes Vg plus Vr into minus J. And if you take magnitude on both sides, this becomes magnitude of vector Vgr, which is actually equal to Vgr, is equal to Vg plus Vr into minus J. Now something else as well, which is the very simple concept. See, this is velocity of A and this is velocity of B. What is the angle between them? The angle between them is theta is equal to 180 degree. So what will be the relation, the resultant velocity? The resultant velocity, or what will be the resultant speed? It will be equal to the sum of these two velocities. Straightforward, right? Now, in the other case, if this is VA, if this is VB, what is the angle between them? The angle between them is 0. In this case, what will be VAB? That will be equal to VA minus VB. So we have discussed these concepts many times and repeated this in almost every numerical that we discuss in motion in a straight line. Okay, so this is the equation what we need here, which is F is equal to dm by dt into minus VGR in the vector notation, and in scalar notation, F is equal to dm by dt into VGR. Now let us try to solve the question. So what did we derive so far? The magnitude of, okay, let me write that as well. So the vector F thrust is actually minus V relative into dm by dt, right? And the magnitude of this vector is Ft is equal to V relative into dm by dt, right? Okay. Now let us consider the free body diagram of the rocket. Let us consider the free body diagram of the rocket, where in a scenario where there is a presence of a gravitational field, unlike in free space. So when there is a gravitational field, we know that there will be two forces, one F thrust and the other what will act on it? Mg. So we'll write it over here. F thrust will act upwards and mg will act downwards. So if you have been following the assigned convention as we did in the previous questions, we know that the net direction of motion is upwards. So all those forces which are acting upwards would be taken as positive. The net direction of motion is upwards, and all those forces which are acting downwards would be therefore taken as negative, right? So if we have to apply the Newton's laws of motion, we can write that sigma Fy is equal to m into Ay. So we can write m into Ay is equal to sigma Fy the other way around. So we can write ma is equal to, what is sigma Fy? Sum of the forces, which is plus Ft, right? Which is plus Ft minus mg. So it's plus Ft minus mg. If you transpose mg to the LHS, what we get is ma plus mg is equal to plus Ft. What is Ft? V relative into dm by dt. And what is mm? We can take common here, so we can mass is 1000 kilogram. So 1000 into what is acceleration? 20 meter per second square, plus what is g? The value of g is 10, equal to what is v relative? Relative speed of 500 meter with respect to the rocket. So this is 500 into 500 into dm by dt. So basically what we get is dm by dt is equal to 1000 into 30 the whole upon 50. So wait, 1000 kilogram meter per second square. Okay, so now this thing gets cancelled, so it is 3000 by 50, and therefore dm by dt is equal to 60 kilogram per second. Okay, a lengthy derivation is the reason why the solution took so long. See, if you write only this much as a solution, then things become really complex, because you may be wondering why is it ft negative, and then why is ft positive here, and then why did we take ft as positive and mg as negative. So all this confusion would arise while discussing only the solution here. That is the reason why I have explained the derivation in detail. I've explained the terminologies in detail. I'm sorry if I made the content go a bit broader. So hopefully you understood it. Let's go to the next question, in which case, which is based on force and acceleration. A particle of mass m originally is at rest is subjected to a force whose direction is constant but magnitude varies with time according to the relation F is equal to F0 into 1 minus t minus d square, where F0 and t are constants. The force acts only for the time interval 2t. Okay, the force acts only for the time interval 2t. The velocity v of the particle after time 2t is. Okay, see, this is a question based on integration, right? Straightforward integration. Those people who are preparing for the JEE Mains, this question is from JEE Mains anyway, you'll be very much familiar with integration, because you're preparing much detailed questions for integration in your maths preparation. But otherwise, I would suggest it's always better to understand the derivation in detail, the solution in detail. And this time I write each and every steps in the detailed way, so that you can understand. If if students are from other background who are not much into maths, for them I'll write the detailed steps. Give me a second for that. Okay, so I have written possibly all the steps in much detail. Okay, so we'll divide the steps in the solution into two halves. Let's first discuss the first half. So what is given to us? F is equal to f0 into 1 minus t the whole square by t square. Okay, by t square. Now we know that we've been asked to find out the velocity here. So what is acceleration? Acceleration is force by mass. Now we can write this as 1 by m into f. Why? Because what we have here is f, right? So this much is f over here. So what we'll do is we'll write this f, we'll replace f by f0 into 1 minus t minus the whole square by t square. Okay, so now this is acceleration. Now why did I bring acceleration? Because we've been asked to find out velocity. And what is velocity? Acceleration can be written as dv by dt. So now I can write the dv by dt is equal to f0 by m into 1 minus t the whole square by t square. Now I'll take dv on the LHS and I'll transpose dt to the RHS, which means dv is equal to f0 by m, both of which are constants, into 1 minus t the whole square by t square dt. Okay, now it is given that the force is acting only for the time interval 2t, which means the upper limit for time is 2t, and obviously the lower limit would be 0. And the initial velocity, it is starting at rest, so for the initial velocity u is 0, and it will gradually attain the velocity v. So the lower limit is 0, upper limit is v. I hope to find out the limit is clear to you. Okay, now keeping this in mind, we'll integrate dv. What is integral of dv? It is v, lower limit 0, upper limit v, f0 by m. Now look at the way I'm going to integrate here. So to avoid confusion and to decrease the chance of getting an error, I'll write capital T as x. Okay, so what did I do here? Replace capital T as x. Why? Because it may be the case that you'll get confused with capital T and small t. So I don't want you guys to have that confusion. So to avoid that confusion, what we'll do is we'll replace t with x. Now comes the detailed part of the solution. Give me a minute. So we know that integral v, okay, with dv is v, weighing from 0 to v, f0 m into 0 into 1 minus m minus x. I've just borrowed the previous equation since I started afresh. Now what I'll do is, since there are two parts within this fraction, I'll just split this integral into two. So I'll splitting one integral into two, 0 to 2t, 0 to 2t. First will be for 1 dt, second will be for t minus x the whole square by x. Okay, my bad, it's not x, it is x square dt. Okay, now what is integral of 1? Integral of 1 is t varying from 0 to 2t. Now see, since x is a constant, I can keep x square outside the integral. So I'll write it as 1 by x square into integral 0 to t minus x the whole square. Now, which formula are we going to use here? See, what is integral x minus a the whole power n? It is equal to x minus a the whole power n plus 1 the whole upon n plus 1. So using this formula, what is integral of t minus x the whole square dt? It is t minus x the whole 2 plus 1 by 2 plus 1, which is 3 by 3. Okay. So the next step, we'll substitute the limits. So upper limit is 2t. So t from 0 to 0 means 2t minus 0. Okay. Yeah, 2t minus 0. Then what we have is 1 by x square into. Here I didn't substitute x because the integral was almost, well, a minor mistake here. It's not capital T. It should be small t, right? Because we are integrating dt. So we have small t. Okay. Now when you integrate small t, what you get is upper limit is 2t. So 2t minus lower limit is 0 minus 1 by x square into upper limit is 2t. So t minus, what is the variable? The variable is t. And what is the constant? X is the constant. So maybe for your clarity, I can write here. That is the thing. That is the variable. So t minus x has to be substituted. T has to be substituted with 2t. So t minus x becomes 2t minus x. Lower limit is 0. So t minus x becomes 0 minus x. The whole cube by 3. So f0 by m, 2t minus 0 is 2t, 1 by x square. Now I'll replace x square with, so I'll replace x square with t again, x with t again. So when we do that, what we have is x square becomes 1 by t square, 2t minus x becomes t, 2t minus t the whole cube, 0 minus t the whole cube, which is 2t minus t is t cube, 0 minus t is minus t the whole cube, right? And therefore what we get is f0 by m into 2t minus 1 by t square. 2t minus t is t cube minus t the whole cube. Minus t the whole cube is minus t cube into minus t cube. Okay, I don't want to have a confusion here. So it's t cube minus, this becomes minus t cube. So what is t cube minus t cube? That actually becomes t cube plus t cube, which is 2t cube. So 2t cube by t square is 2t by 3. 2t minus 1 by 2t minus 3. I'll multiply 3 on the numerator and the denominator. So what is 6t by 3. 6t minus 3t is 40. And therefore, v is equal to f0 by m into 40 by 3. A very lengthy derivation. See, for, when you put it for the exam point of view, you don't write these many steps just to try to make things very faster, which is something very easily you can do. So very simple integral. But again, since many students may find this integration tough, the first time they do it, I've taken some time to detail it. Having said that, let's move on to the next question, which again is based on force and acceleration. A force F is equal to 40I plus 10J acts on the body of mass 5 kg. If the body starts from rest, its position vector r at time t is equal to 10 seconds will be its position vector r. Okay. Very straightforward question based on the application of equations of motion. So we have F is equal to 40I plus 10J. So what is S is equal to ut plus half at square, all in vector notation. So since this body starting from rest, the initial velocity vector will be equal to 0. So all we have is S is equal to half at square. What is A? A is F by M. What is F given to us as 40I plus 10J. So this becomes 40I plus 10J divided by M. M is 5 kg. It is 5. So 2 into 5 is 10. 10 t square at the time t is equal to 10 seconds. So t square will be 10 square. So 10 square is 100. 2 into 5 is 10. 100 by 10 is 10. 10 into 40 would be 400, 10 into 10 would be 100. So displacement vector S is equal to 400I plus 100J. Okay, I don't think I have all the options here, so the correct option would be 400I plus 100J. Let us go one step further in this question. Why? Because most of the time there is a trend in these kind of questions. So similar questions do come up. So let's see. If vector S can be written as Sxi plus Syj, it actually means that the x component of this displacement vector is equal to Sxi, and the y component of this displacement vector S in the y component is Sy into j. In fact, if you write this even further, what is magnitude of S in the x direction? It is Sx. And what is magnitude of S in the y direction? It is Sy. And what is vector S? The magnitude of vector S is equal to root of Sx square plus Sy square. Okay. So yeah. Okay. So let's now discuss the next question. This actually, if you try to understand this is a very similar question to the one what we did some time before. So it says a boy pushes a box of mass 2 kg with a force F is equal to 20I plus 10J on Newton on a frictionless surface. If the box was initially at rest, then the x-axis after 10 okay then right. Okay, so I think the question is then the displacement along the x-axis after 10 seconds, and the displacement along the x-axis after 10 seconds is. So very straightforward application of the previous question. Okay, so how do we approach this? We have been given vector F is equal to 20I plus 10J. Initial displacement, initial velocity is 0. Time is 10 seconds. So ut becomes 0t. Half A becomes F by M. T square is 10 square, which is 100. F is given to us as 20I plus 10J. Mass is given to us as 2 kg. So by 2 kg. I'll write displacement vector S as Sxi plus Syj. Why is Sx highlighted here? Because we've been asked to find out the displacement along the x-axis. So we need to find out Sx. So 1 by 2. 2 into 2 is 4. 100 by 4 is 25. 25 into 20 is 500. 25 into 10 is 250. So this is 500I plus 250J. And if you understand the concept here, if you compare these two vectors, the x component vector should be equal, which means Sx I cap should be equal to 500 I cap, and similarly Syj cap should be equal to 250 J cap. So if Sx I cap is 200 I cap, if we take magnitude on both sides, what is magnitude of I cap? It is 1. So what is magnitude of I cap? It is 1. What is magnitude of Sx? It is Sx. So what we get is magnitude of 500 is 500. Magnitude of I cap is 1. So Sx is equal to 500. So the next component would be 500. Okay. So that's a very similar question to one we did before. Now let us try to do the next question, which okay, so this is the question that's based on the variable velocity question. Okay, not variable velocity, this is based on force as a function of velocity. Okay, a spaceship in space sweeps stationary interplanetary dust. As a result, its mass increases at okay, I think it's at a rate of where dm by dt is equal to bv square, where v of f, okay, it's not v of f, it should be v of t, is its instantaneous velocity. So the instantaneous acceleration of the satellite is. Since we did a very similar question, I would say just which question was it? Okay, so it was just 4 questions, before doing this one. So I don't want to go much into the derivation. Let's directly get into the answer. And this time, let's use the let's use the force impulse theorem. Okay. So okay, know that the force external acting on the body will be used to change the momentum of the body, right? So F external is equal to change in momentum, where rate of change in momentum, which is dp by dt. Now, what is P here? P is momentum, which is mass into velocity. Now, if both of these are considered to be variables, then we know that this becomes m into dv by dt plus v into dm by dt. And since both of them can vary according to time, given that it is a function of v is a function of t, which is v of t, which is given to be instantaneous velocity, it means that velocity is a function of time. And so is mass given as a function of time, which is m of t. So this m can be replaced by m of t and v can be replaced by v of t. So now we have m of t into dv by dt plus v into d by dt of mt. Okay. Now, see, when it comes to the comparison of rocket, what we need to understand is the rocket equation will have two parts. One, when the rocket is within the gravitational field, and one, when the rocket has crossed the gravitational field and it has reached the space. In space, the external force acting on the rocket will totally be equal to 0, whereas in gravitational field, F external will not be equal to 0. In fact, we have discussed this in much detail that the F external acting in gravitational force is nothing but the acceleration due to, the force due to acceleration due to gravity, which is the weight of the rocket, right? So that component is not present in free space. So in free space, F external is equal to 0, which means we can replace this term as 0. And therefore what we have is m of t into d by dt of vt. Now see, what is acceleration? What is acceleration? Acceleration is equal to rate of change of velocity, which means if you differentiate instantaneous velocity, what should be you be getting? You'll be getting acceleration instantaneous or a of t. So d by dt of vt, since a is equal to dv by dt, what we get is d by dt of v of t, you will get a of t, which stands for instantaneous acceleration. Plus, instead of v, we'll write as v of t because it is given that velocity is a function of time. As v of t. And what is dm by dt? See, this is where we come back to the question. So dm by dt is actually given to us as b into v square, which is actually b into v square of t. Okay. So we have a of t, b v square of t. Now, what I'll do is I'll transpose. Okay, first let me just multiply this term. So now this becomes v of t into v square of t, which becomes v cube of LHS. So what we get here is minus bv cube of t is equal to m of t into a of t. And we've been asked to find out. Instantaneous acceleration. So this basically becomes minus bv cube by t minus b cube by t the whole upon m of t, right? So the correct answer is minus bv cube. Okay, I don't have the options here, so I think that's clearly given in your handout. So which option is this option? Yeah, that's option C. So minus bv cube by m of t. A small ball of mass m is thrown upward with velocity u. From the ground, the ball experiences resistive force mkv, where v is at. Yeah. Oh, okay. Sorry. My bad. Okay. It's, you say it's v mkv square. Okay. So mkv square. Okay. The maximum height attained by the ball is. See. Let's go back to question number 19 or question number. Question number 17, right? Yeah, 17. So you see, this question is almost similar to question number 17. Okay, that's a typical application of integral calculus in equations of motion. So, let's first draw the free body diagram and try to understand what's given in the question. So what we need to understand here is, if we approach the free body diagram of the ball here, this is the ball, okay? Weight is acting downwards and the ball is experiencing a resistive force. See, what does this mean? Resistive force will always oppose the motion, right? So the ball is thrown upwards. Now what will the resistive force do? It will oppose the motion, which means it will be acting against the upward direction, which means it will be acting downwards, right? I hope this much makes sense. Now, we have two forces, both of them acting in the opposite direction to that of the net direction of motion. So what we'll do is, for our convenience, we'll take the all the forces acting to along the direction of motion as positive and those which are acting against the motion as negative. So it will be negative mg and negative FR, which is negative MKV. Okay. Oh, yeah, sorry. So it's MKV square. My bad. So, applying Newton's equations of motion, what do we have? Sigma Fy is equal to m into Ay, right? What is sigma Fy? Sum of forces in the y direction. How many forces are there? Two forces are there. What is their magnitude? Mg and mkv square. What's the sign? Since both of them are acting against the direction of motion, we'll take both of them to be negative. Therefore, both of them are negative here. Is equal to m into Ay. Now, in this equation, I'll divide this complete equation by m. What do I get? M by m is 1, mm is 1. So I'll take negative common, so that becomes g plus kv square is equal to Ay. So what is the net acceleration on this body? It is the negative sum of g plus kv square. Okay. Now let's try to bring in one more concept. See, we have used this derivation many a times here, that we said that A is equal to V into dV upon dx, right? Something that we've been using. I think in this set of questions we use it twice. This is third time. So A is equal to V into dV by dx. Now we are considering vertical motion here, so this can be written otherwise as A is equal to Ay is equal to V into dV by dy. Now what is Ay? We just derive it to be minus of g plus kv square. V into dV by dy. Now look at this. What I'm going to do is I'm going to bring this g plus kv square to the RHS, and I'll keep dy and negative on the LHS. Okay. So it would look something like this. So we have minus, right? Minus and dy kept here on the LHS. I'll take g plus kv square to the RHS. So now in the RHS we have dv and v by g plus kv square. Now a little bit of algebraic manipulations. So we'll focus on multiplying. We'll focus on the denominator. Why? I'll tell you what. So the variable is dv, right? Sorry, v is the variable here. So what is the coefficient of v? Coefficient of v square, it is k. So what I'll do is I'll multiply 2k on the numerator and 2k on the denominator. Why? See, now being a student of JEE Mains, this question shouldn't come into your mind. But if you're from the NEET background, or if you're not, or maybe if you're approaching this for the first time, I would say let's try to understand the substitution in detail. What I have done is I have multiplied this by 2k in the numerator and 2k in the denominator. Why? I'll tell you. See, what is derivative of g plus kv square? It is actually d by dv of g, which is a constant, plus k into d by dv of v square. We know this value is equal to 0. Why? Because it is a constant, and this what we get is 2k into v. So in the numerator, what we have is v, right? In the numerator, what we have is v. So, okay, to make it more clear, we needed 2k. We need the coefficient to be present along the numerator. The coefficient is 2k. So I multiply the numerator with 2k. So if I multiply the numerator with 2k, I'll have to divide it with 2k, because only then the entire fraction will remain the same, right? Okay. So let's now see what this represents. See, d by dv of g plus kv square is 2kv, right? Which means instead of 2kv, I can write here d by dx of g plus kv square. Okay. And what is in denominator? It is g plus kv square, which means this is actually now of the form. Okay, wait, I missed the dv here. So it's dv here. And now if you integrate on both sides, the integral on the RHS will be of the form integral of f of x g plus kv square into f dash x d by dx of g plus kv square dv, which actually is log f of x, which in this case is log g plus kv square. Okay. Now, since this is based on definite integration, how? Because it is from height h is equal to 0 to h is equal to h max. Okay. What is the velocity at h is equal to 0? Let's say it is va. What is the velocity at b? it is VB. Now, since it is projected from A, we know that VA would be equal to U. And any object when thrown upwards, the maximum height, it will be momentarily at rest. It will come to rest for one moment, momentarily at rest. And at that point, VB would be equal to 0. So height will vary from 0 to h max, or let us take a capital H, and velocity would vary from u to the maximum velocity is 0. So limit varying from u to 0. Now if we were to do the rest of the calculation, this becomes minus y varying from 0 to h. So instead of minus y, now I can write minus h minus 0 is equal to 1 by 2k times, okay, ln. Now instead of v, we'll have to substitute 0. So this becomes g plus k into 0 square, right, minus ln g plus k into, instead of v, we'll now substitute u, which is u square, okay. So this is minus h is equal to 1 by 2k whole times k into 0 is 0. So we can write here this is ln g minus ln g plus ku square, right? Now let's make use of this property. What is ln a minus ln b? It is ln a by b. So this becomes minus h is equal to 1 by 2k times ln into g by g plus ku square. Now we can also write one more equation, that ln ab is actually equal to minus ln. So ln a by b is equal to minus ln b by a. Therefore, if I multiply this by entire minus, this becomes h is equal to 1 by 2k into ln. Now using this property, I can write it the other way around. This becomes k u square, g plus ku square by g. Therefore, what is h is equal to? So h is therefore is equal to 1 by 2k into ln. G by g is 1 plus ku square by g. Okay, so yeah, a bit lengthy one. The reason why I made it so elaborate is to make sure that you understand each and every step behind it. Okay, so well, if you get a guess of this, I think you should be able to do the next question on your own, which again is the same concept. Don't go any further. You can use a is equal to dv by dt or a is equal to v into dv by dx, and you can come with the same answer. Okay, maybe a similar kind of application of integral calculus as well. Let's see. A ball is thrown upward with an initial velocity v0 from the surface of the earth. The motion of the ball is affected by a drag force equal to okay, this is actually mkv squared, my bad, where m is mass of the body and v and v is its instantaneous velocity, and it's not y or k, is a constant. Time taken by the ball to rise to the zenith is. See, now I think we did a question similarly, a similar one based on finding the maximum height to which the ball is reaching, and therein we use the concept of integral calculus. So this is a very similar question, and we'll use a very similar way of deriving the answer. See, this I have to admit, the solution is going to be a bit lengthy because this is integration, and I'll make sure that every step is explained in detail. So if you're thinking that how long would it take to solve these kind of questions in the real exam, well, ideally it shouldn't be taking much time because you don't write much steps, right? You know what the integration is. You do submit the lower and apply the lower and the upper limit, and you have the answer in a very quick manner. However, here what we'll do is we'll try to make sure that every step is detailed and we understand the mathematical part of this problem very clearly. Having said that, let's move on to the solution. So this is the visualization here. So we have ground, which is at height is equal to 0. The object is thrown up with the velocity a from reference position A. It's retards as it goes upwards. It reaches B, its velocity becomes 0, and at that point it is momentarily at rest. And when it is momentarily at, the corresponding height is in the maximum height, which is h max, which is what we always call as the zenith position, right? And then the object comes down. The question is to find out the time taken by the ball to rise from A to B. So let's try to understand the free body diagram of the ball. So we have the ball here. The ball is moving upwards for the motion along AB, right? For the motion along AB, the net direction of motion is upwards. How many forces are acting on it? There are two forces acting on it. One, which is the weight of it. Second, it is affected by a drag force, which means drag force is actually a resistive force, so it will be opposing the net direction of motion, right? So the net direction of motion is upwards. There are two forces acting against it, which is downwards. Now, if we use Newton's laws of motion, we have sigma Fy is equal to m into Ay, right? What is Ay? Is dV by dt. And why are we not here using v into dv by dy? Yeah, exactly. Very good. Now, those who are watching it online, please make sure that you try to answer this. Okay, so yeah, so that's it. So now what is sigma Fy? Sigma Fy is the sum of forces in the y direction. How many forces are there? There are two forces. What are their magnitudes? The magnitude is W equal to mg and Fd is equal to kmv square. Now, how do we choose their sign? The net direction of motion is upwards, which means the opposite, these forces are acting in the opposite direction, their sign will be minus. So we have minus mg minus kmv square is equal to m into dv by dt, right? So, okay, give me a minute. Now, I'll divide this complete equation by m. So what we get is minus mg by m minus kmv square by m is equal to m by m into dt by m by m by m by m is 1. So these terms can cancel off. I can take one negative common. So what I get is negative of g plus kv square is equal to dv by dt. Then I'll transpose this complete term g plus kv square to the right hand side. So we get dv by g plus kv square is equal to minus dt. Now see, a small manipulation here. In this step, in this complete denominator, I will divide it by the coefficient of v square. What is the coefficient of v square? The coefficient of v square is, let me just write it down here. Dividing by coefficient of v square, which is k. So now I have g by k plus kv square by k. So k by k is 1 and now we have g by k. Okay. Now since I am dividing it by k, I'll also have to multiply it by k, right? So we have 1 by k over here. Okay. Now, okay, so some students may have a doubt here. What I did is I just multiplied this complete denominator by k and I also divided by k and also multiplied by k. Okay, that's what I've done. And this k, I have written it as 1 by k in this step. Okay, now instead of g by k, I have written root of g by k the whole square. What does it mean? Well, it basically means like this. So we have a by b can be written as root of a by b the whole square. Why? Because this root a the whole square, which is a, root b the whole square, which is b. Same logic. Okay, and then we have b square. Now if you see, this is of the form, this equation is of the form integral dx by x square plus a square, which is actually 1 by a tan inverse x by a. Now what is a here? A is root of g by k. Okay, so if we do the integration part, now what we get is, so we know this is we know the integral is 1 by a tan inverse x by a, where a is equal to root of g by k. So we have 1 by a into integral dv by root of g by 1 by k into the integral. Now what is the value of this integral? The value of this integral is varying from dv is the velocity is from u to final maximum velocity is 0. Why that limit? Because the ball is projected from a with some velocity u at the final point b, which is the h max, which is x max, the velocity, the body is momentarily at rest and therefore the velocity there is equal to 0. So it's equal to 0. Now what is the integral? 1 by a. What is a? A is root of g by k. So 1 by root of g by k into tan inverse x by a. Instead of x, we have dv. So v by a, which is root of g by k. Now we'll apply the upper limit and the lower limit. So we have 1 by k into upper limit minus lower limit. So this is upper limit. So we have 1 by root of g by k tan inverse. Instead of v, we'll have 0 minus 1 by tan inverse a, which is lower limit, which is u, right? Now what is tan inverse 0? Tan inverse 0 is 0. So 0 into 1 by root of g by k base 0. Now this remains 1 by root of g by k into tan inverse u by root of g by k itself. There is no variation in that. So if I take this further, this becomes minus t is equal to y minus t, because integral of dt is t. We have minus here. Upper limit minus lower limit is t minus 0, which is minus t. So now this becomes plus into minus. This becomes minus here, right? This and minus, these two minus, will cancel. Minus by minus becomes plus. So these two becomes plus. 1 by k into 1 by root of g by k. See, now instead of root of g by k, I'll make the step more clear here. Can I write this as root g by root k, right? So 1 by root g by root k will become actually 1 by root g into root k, right? Now what is root k? Root k is k to the power 1 by 2. So I can write as k to the power 1 by 2 by root g. So this is k to the power 1 by 2 by root g, okay, into u. 1 by root g by root k is the same logic. K will go to the numerator. So we have root k into u, okay. So I think that much portion is clear. Now if we go to the next step, what is 1 by k? Okay, so I think I should clarify this thing. So now we have k here, and root k by 2 into k raised to 1 by 2 denominator. So this is k by 2 by k, which is equal to k to the power 1 by 2. This is 1 minus 1, which is k to the power minus 1 by 2, which is actually 1 by k to the power 1 by 2, which is actually 1 by root of k. And that's how we get 1 by root k in the denominator, and the rest of the value remains unchanged. So this is the expression for the time of well, not the time of flight, but the time of ascent, to be moved, time of ascent. Okay. A particle of mass m is moving in a straight line with momentum p starting at time t is equal to 0. A force F is equal to kt acts in the same direction on the moving particle during the time interval t, so that its momentum changes from p to 3p. Here k is a constant. Then the value of t is, so it's a constant force acting on it, right? No, sorry, it's a time variable force, which means we can integrate. So if we were to visualize this question, what we have is an object moving of mass m moving under the influence of force F is equal to kt from time t is equal to 0, and the momentum is now p. After some time, the momentum becomes 3p. Okay. Now, what time interval is required to change this momentum from p to 3p is the question. Okay. So time 0, the corresponding momentum is p. At time t is equal to some t, say unknown time t, the corresponding momentum is 3p, and we know that F external is equal to dp by dt. What is F external here? Given to us as kt. What is dp by dt? We will write dp by dt as dp here, and we'll transpose dt to the LHS. So we have kt into dt. Now it is t into dt, so the integral is t square by 2, varying from 0 to t. Why from 0 to t? Because time is from 0 to t. And corresponding dp, the integral is p, varying from p to 3p. Why p to 3p? Because the initial momentum is p is equal to mp, and the final momentum, according to the question, is changes from p to 3p. So lower to higher, p to 3p. Substituting the final limits, we have k into t square by 2, lower limits minus 0 square by 2, 3p, upper limit, lower limit minus p. So t square by 2, 0 square by 2 is 0. K into t square by 2 is equal to 3p minus p is 2p. So t square is equal to 2 into 2 is 4. 4p by k. T is equal to root of 4, which is true. Root of p by root of k. T is equal to 2 into root p by k. A particle of mass m is acted upon by a force given by the empirical law F is equal to r by t square. If this law is to be tested experimentally by observing the motion starting from rest, the best way to plot this. So given F is equal to r by t square, right, into v of t. Now what is F? F is equal to ma. and a is dv by dt. So f is equal to m into dv by dt, r by t square into v of t, which is actually a function of t. So I'll keep dv here. I'll bring v of t to the LHS. R by t square into, I'll bring m to the RHS. So we have r by m into, instead of this t square, and it is 1 by t square. Okay. Now, what is integral of, okay, let me write it here. So what is integral 1 by x dx is equal to? It is log x. So we have log vt here. And what is integral 1 by t square? So integral 1 by t square is equal to, or to be more precise, integral 1 by x square dx is equal to minus 1 by x. So instead of minus 1 by x, we have 1 by, so instead of 1 by x square, we have 1 by t square. So instead of minus 1 by x, what we get is minus 1 by t. And if we try to understand this equation in the mathematics sense, what we have here is one constant, one variable, ln vt, we'll call that as y, is equal to m into x, which is minus 1, say for example, I'll put this minus over here, my bad, right? Okay, so now we have this is y is equal to m into x, where x is 1 by t plus c. So we don't have c here, which means 0, right? So if we draw a graph with the y-axis represented as ln vt, x-axis as 1 by t, the slope of this tangent will give, sorry, slope of this graph will give us minus r by m. And therefore, the best way to study this, to plot this, is to plot ln vt versus 1 by